The payloads of the IOV satellites have much the same design as those tested with the Giove satellites, with advanced technology systems such as the atomic clocks and the navigation antenna. For a satellite navigation system to work, a receiver on Earth needs to simultaneously receive the signals of 4 satellites. They circle the Earth at 23,000 kilometers in 3 orbital planes. The receiver computes its own position by calculating the difference in the received signals from the satellites that will be in its visibility. But the Galileo system is, in fact, one vast space clock. The signals broadcast by the spacecraft must be rigorously synchronous, timed by identical clocks. Each spacecraft has 4 atomic clocks. They work like conventional ones, but their time base, instead of an oscillating mass as in a pendulum clock, use the movement of atoms, their property to switch rapidly between different states of energy. It is the frequency of this transition that is fed into a counter. Each IOV spacecraft has 2 types of clocks. The so-called passive hydrogen maser is the most precise clock ever placed in orbit for navigation, accurate to 1 second in 3 million years. Its backup is a rubidium clock, accurate to 3 seconds in 1 million years. The master clock's timing precision is critical to achieve the accuracy of the Galileo service. An error of a single nanosecond, that is 1/1000th of a second, implies a ranging error on the ground of 30 centimeters. If translated to a second, this represents an error of 300,000 kilometers. Instead of being in one's car on the way home, one might as well be on the moon. To achieve this extreme time stability, the satellite's operating conditions and its environment are also paramount. So the satellites have been designed to maintain constant operating conditions. Temperature variation is limited to 1/10th of a degree, which is a remarkable feat considering that the spacecraft pass regularly from sunlight plus 100 degrees Celsius to shadow minus 150. The Galileo system must also take into account the space environment, such as radiation level, that changes along the orbits that the satellites follow, with resulting slight variations in the propagation time of their signals. Finally, there is the ground segment. The tracking stations around the world and the 2 control centers in Germany and Italy must equally beat like metronomes, rigorously in step with the satellites, capable of predicting their precise position and timely contacting them to upload freshly computed navigation correction instructions. It is the combination of all these elements that will allow Galileo to provide precise and guaranteed positioning services.